Problem solving and data analysis is sort of the black sheep of SAT math. But if you're aiming for an 800, you can't ignore it. So in this video, we're going to go over 5 hacks to help you get that perfect SAT math score that you are aiming for.
First up, we've got percentage shortcuts. The first being how to add percentages. And basically to add percentages, you're going to do 1 point whatever, or the better way to think about it is take whatever percentage and add 1 to it after you convert it into decimal form. The logic being that the 1 is going to be your original 100%, and then the percentage that you add on is going to be the additional percentage. Importantly, on this question, we're being asked to add 110%. So we have to think 1 plus 1.1 for our 110%. So in truth, it's going to be 2.1. And once we know that, this is a pretty darn easy question, especially if we just plug it right into Desmo. So let's do that. And I like to use the bracket system of equations method here. W is squiggly 2.1, that's 110% greater. And then our next equation is Z is 55% less than 50, which brings us on to subtracting percentages. And to do this, basically you take whatever you're going to subtract it from 100 and convert it into decimal form. So if we wanted to subtract 35%, we would multiply it by 0.65, since 1 minus 0.35 is 0.65. So for this one, 55% less would be 0.45, since 1 minus 0.55 is 0.45. So back to Desmos, we have Z is 0.45 times 50. So again, that's 55% less than 50. And then our answer for W is 47.25. And then finally, when you're being asked about percent change, so basically this is talking about a percent increase, you want to use the percent change formula, which is basically the difference between your original and new value divided by your original value. Just keep in mind that this is going to give you a decimal, so technically you would also multiply by 100 in order to get it back to an actual percent. Anyway, following this, it says that the manager estimated that the percent increase from 2012 to 2013, so the one that we're seeing here, would be double the increase from 2013 to 2014. So whatever happens after that. So first, let's figure out our percent increase between 2012 and 2013. And again, remember that's going to be your difference divided by your original. So the difference would be the bigger number minus the smaller number. So 5880 minus 5600. And that's going to be divided by the original, which was the 5600. That's where we started. So 0.05 means we had a 5% increase. So 5% increase. And the manager estimated that this 5% increase would be double the increase of 2013 to 2014. So we want to cut that in half, since it would be double what we're looking for. And we want to take our number 5880 and we're going to increase by, that's right, 2.5% or 1.025. Going back to how we add percentages, right? So our answer there is going to be 6027, which is choice B here.
Okay, buddy, I see how these hacks could be useful, but what if I forget them?
You're right, you don't want to forget these hacks, and what you need to do is you need to practice. So I went ahead and made you guys a free question set. Just use the link in the description and you can practice what you just learned.
My dude, thanks so much.
Next up, we've got the median trick. And some of you are thinking, what the heck, dude, median trick? We don't need no trick. We could just put median into Desmos, put a list of numbers separated by commas, and it's going to give us the median, right? Okay. You could also easily find it in a short list by just finding the middle number after rearranging them. But what happens when you have a larger list like this one with 19 neighborhoods? This is where the median trick comes in handy. And it goes a little something like this. You take your total number of values and divide by 2. So in this case, it would be 19 divided by 2. That's obviously going to be 9.5. And when you get a decimal like this, because you have an uneven number, you're going to round up to 10. Now, importantly, 10 is not your median. Instead, the 10th value is your median. So now you just have to count up and find where the 10th value lives. So here we have 3 values. So that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So the 10th value is going to live here, where we have 13 to 17 chads, meaning our answer has to be 15, since it falls within that range. And in case you're wondering, if you had an even number, so let's say we had like 20 neighborhoods in this town, and we'll just add like a third neighborhood here, then you would do 20 divided by 2, which is 10. And instead of rounding up, because we're already at a whole number, we're going to include the 11th and get the average of those two values. So in this case, we know that our 10th value was here. Our 11th value is also here. So either way, we would end up with 13 to 17 because basically 13 to 17, the average of that would still be 13 to 17 since it's two of the same value. So there is your median trick. Next up, one of my favorites is the little Timmy trick. Give it up for little Timmy, ladies and gentlemen. There he is. Yeah, he's kind of a sad guy, but he's very useful because he is meek. He is not confident. He is not sure of himself. And while usually this is not a good thing in life when you're trying to get ahead, it's a good thing when you're answering this type of statistics question where they're asking about some sort of an interpretation of a study. So basically, they're telling us what's a correct statement based on the given margin of error. So behaving like little Timmy, we're going to completely ignore the passage and the chart here, and we're just going to eliminate any confident answers that give definitive statements. So the word approximately is nice because it's sort of hedging, not being too sure of oneself. But choice B, it is not possible. That is way too confident. Little Timmy would never say that, so we're going to get rid of it. Choice C, the percent of all US adults is exactly. That is a definitive, absolute statement. Little Timmy would never be so confident to say that. And then choice D, it is doubtful. Timmy would say that. Okay, now we just have to figure out what our actual question is. So it's asking about given margin of error. And as you guys ought to know, a margin of error is basically going to be a range that goes below and above the results of the study. So in this case, since our result was 42 and our margin of error is 4, we would go 4 below 42, so that'd be 38, all the way up to 4 above 42, which would be 46. So if we look at choice A, it says approximately 4% are misclassified. That actually has nothing to do with margin of error. So a little bonus tip for you, make sure you actually know what margin of error is. And then choice D, it is doubtful that the percent is 32%. Since our margin of error's lowest percent would be 38, it is doubtful that it would be all the way down to 32. So that is our answer, choice D. My next hack is the given that hack. And this is simply the fact that given that is going to apply not just to your numerator, but to your denominator. And I'm pointing this out because I've had a ton of high scoring students miss questions because of this, and I don't want you to do the same. So if we didn't know this, what happens to a lot of my students is we're trying to select something at random, and it's saying, what's the probability of selecting a flower from site A? So we'd be kind of honing in here, given that the flower is a tulip, and then we'd be honing in here. And we'd say, cool, that's 35 is what we're looking for out of our possible, and it did say we're selecting at random, so that would be the whole thing, and it'd be 35 out of 102. We would simplify that, and we would be wrong.
Wrong, 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 wrong.
Instead, we need to make sure that we understand given that applies to our population as well. We're honing in on site A as the actual desired outcome, but then given that is going to restrict our population. So in truth, our intersection here is going to be our numerator just like before, but our total is only out of 50. So we're going to simplify that fraction. I believe that's going to be 7 out of 10 or 0.7. So our answer is going to be either 7 out of 10 or 0.7. And then finally, I've got unit conversion squared. And this is going to be another type of question that tricks some of my high scoring students into missing out on basically free points. So you've got something like this where you know you have to convert square yards to square miles, and they give you the conversion, and you're like, oh, that's so sweet of you. As long as I don't screw up my numerator and my denominator, I should be good here. And speaking of which, I do like to use stoichiometry. So basically you turn your stuff into a fraction. So I would have my square yards on top here that I'm starting with. And this is just, over 1. And importantly, we want to keep our unit here. So yards squared. and then we're multiplying by our conversion rate, yeah? And the reason I like to set it up like this is I know that I want to get rid of yards, so I know that my yard should be in the denominator. That way, when I eliminate the numerator and the denominator, because we can do that if we're multiplying fractions and we see this same unit in the numerator and the denominator, so then my 1760 would be down here, and then my 1 mile would be up here. So basically, after we eliminated the yards squared, we would be left only with miles. And this is the mistake that a lot of students make, because if we throw this into Desmos, I'm gonna get this answer here, which lines up perfectly with choice D, and I'm gonna circle choice D, and again, I'm gonna be wrong.
Wrong, 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 wrong.
The conversion rate they gave us is not miles squared to yards squared, it's just miles to yards. And if we look at my little stoichiometry setup, this should also be a red flag, because in order to eliminate the numerator and the denominator here, I need the same thing, but yards squared is not the same thing as yard, right? And furthermore, miles squared is what I'm looking for, not miles. So to fix this, I'm simply going to square all of this. That way I get yards squared, and I'll square all of this. That way I get miles squared. The miles aren't such a big deal because 1 squared is still 1, but 1760 squared is going to be a lot different than 1760. So we just go ahead and square that sucker. Now it says 3.83, which is choice B, and our actual answer. And yes, in case you're wondering, this kind of trickery does show up not just with squared things, but also cubed things. So be on the lookout for that as well.
So not paying attention to the wording is definitely one way to lose points. Another way is to not practice. So do the right thing. Click the link in the description, get your free practice question set, and practice what you just learned.